Good evening, this is Angel Badillo, and today I'm going to be going over iteration 4 of our Scholarly application. The team leader for this iteration is Kitulwasi Kunene, and our team name is Software Engineering Execution Squad. So a quick overview of what we'll be going over is architectural design, applied design principles, use cases, accomplished work, and the presentation video, which is this presentation video. So onto the architectural design. The architectural design objectives are as follows. The system must provide a responsive graphical user interface that is easy to learn and operate. And the system must hide the implementation and information of how data is processed in the backend. So, for example, it should hide the database implementation in our system. And the system must provide networking communication abilities involving hypertext transfer protocol secure with secured web servers or services, because we'll be needing that to communicate with Google APIs. And more objectives that we have is for our system to support network communications involving simple mail transfer protocol with secured mail servers or mailing services. And more specifically, those services we'll be using is the Gmail API. And our system must be designed to support object persistence for temporary and long-term storage of data generation that happens during the execution of our program. So some design considerations we have for our system. Our system must have ease of change and be relatively easy to maintain. It must be designed in such a way that future changes can be performed with little to no problems. And another consideration is software fault tolerance. Our system needs to be designed to consistently provide its services to our users with little downtime. And in this system, we'll be using commercial off-the-shelf parts, meaning we'll be using Google APIs. So our system must be designed to seamlessly communicate with these other necessary online services, such as Google Authentication, Gmail, and Google Forms application programming interfaces, or APIs. So more considerations for this system are reliability, because our system must consistently provide accurate results to the user, because we're going to be dealing with student information and financial awards. And our system must have system performance in mind, so our system should be capable of processing large amounts of student data in a rather reasonable amount of time. And another thing we have to consider is security, because we're going to be dealing with sensitive data, and that sensitive data should not be distributed or uploaded over the internet without explicit consent from the authorized user. And our system must only perform these communications over the internet when absolutely required to prevent from theft of our data or tampering of the sensitive data. So the overall type of system that our application can be classified as is an interactive system. There are several layers to the structure of our system. There is a graphical user interface layer, a controller layer, a business objects layer, a database layer, and a network communication layer. The system must respond to all requests sent by the actor, meaning this is definitely an interactive system for that reason. Our system only interacts with a single actor, a single user more specifically, but there are other actors, which are the subsystems in our system, and that happens during the process of a use case. And these interactions follow a relatively fixed sequence of steps between the actor and the system, and the format of the system responses are fixed. So every time you go to create a Google form for the Outstanding Student Awards, the system response is relatively the same. Same for scholarship acceptance letters and for creating scholarship criteria. So now we're going to identify our subsystems. So we're going to talk about the main GUI class. So our main GUI class in the code is called Scholarly Main Window, and it's an interactive system. So the interactions between this subsystem and the actor are a fixed sequence of steps, because the actor will always interact with the graphical user interface in a specific manner. And the system responses adhere to a consistent format for a given use case. This is pretty similar to what I said about the overall system, except when we classify this subsystem as an interactive system, we mean that it communicates with other subsystems as needed to perform the necessary functions. And it has multiple layers. It's the same ones as the overall system. And the state of the system reflects the progress of a use case. And also the interactions between the system begin and end with the actor, which is the user. And on to classifying our database manager class. So in the code, it's called Scholarly Database, and it's a database or object persistent system. This class provides retrieval and storage capabilities of business objects for other systems in our overall system. And the only responsibility of this subsystem is storage and retrieval of our objects or business objects. And it hides the database implementation from the rest of our system and other systems, and it's capable of fast lookups and updates and insertions of data. And our objects that we store in here are student records and the scholarships or award criteria. And the last subsystem our system has is the Google API request modules. When you put all those modules together, they're pretty much one subsystem, and it's pretty much a client-server system because the client is our user, or pretty much our application, and it communicates with Google servers or Google APIs for the purposes of sending emails, creating Google Forms, and authenticating the user with their Google account. And the client is the user in this case, which sends requests via subroutines and the aforementioned modules. And here's a quick look at our system block diagram of the overall system. So we have a user. The user interacts with the graphical user interface layer, and whenever the user makes any requests, it goes to the controller layer. The controller layer decides if it's going to create business objects or interact with existing business objects in the business object layer, or it can make a request to the database layer. And if needed, there will be communications between the database layer and the network communication layer for creating Google Forms or sending emails. And the architectural style used by our application is N-tier architecture. So as you can see in the previous slide, there's multiple layers or tiers, and this system is an interactive system, so it pretty much coincides with each other. And the modules and classes are designed to facilitate high cohesion, and the code is separated in many modules and classes that really have the minimal required knowledge of each other to separate concerns and maintain low coupling. So on to the applied design principles. So the first one that we applied in our code is design for change. So here's the database manager class that I mentioned before. It's designed to be easily changed with little to no changes in other modules that make use of it. Any changes to the database would only require modifying this class or any other things in the module. So as you can see right here in the red box, these are all the functions. The user doesn't need to know anything about the underlying implementation. They just need to know about these functions, and the input and the output of these functions will be the same. And this is what it looks like when we use the database in our main window class or the graphical user interface. So the GUI class does not directly operate on the database. It uses the methods of the database manager object, and as long as the expected input and output remain the same, there should be little to no changes in the main GUI class. And over here is another example of where it's being used in there. And the other thing we need to talk about is high cohesion, another design principle we applied in our program. The functions in a module directly correspond to the module's core functionality. So here's one example, the Scholarly menu bar. Every method in this class corresponds with the menu bar, and the only class in this module is the Scholarly menu bar class. And since the class's methods only correspond to actions performed on itself and not other objects, this is an example of high cohesion. And here's another example with the Scholarly icons class. So it makes use of these other enumeration type classes, and it's for the sole purpose of creating icons. So everything in this module is for creating icons for our application, and since they all fulfill the same purpose or functionality. It's high cohesion because they do not do anything other than really create icons. And onto information hiding. So these are around in this red highlighted box are some private variables that cannot be accessed outside of the class, as you can see with the double underscore. So this is information hiding because other classes or other objects do not know of the underlying implementation. And other parts of our system that interact with the database through an instance of the Scholarly Database class object, they don't know about the underlying implementation, they can't access those private variables, and they don't even know exactly what kind of database we're using in the back end. All they know is that these methods have an expected input and output, and it pretty much shields the implementation from all outside entities of the Scholarly Database class. And on to separation of concerns. All the modules or PI files focus on a particular aspect of our system, such as functionality that must be delivered by the system, graphical user interface components, and such. Each problem is tackled in isolation rather than all being done in a single module at the same time. And as you can see in these red highlighted boxes are all the .py files. Given by the names, you can just infer that each module performs a specific purpose for our system. And on to the use cases, which I'll hand over to Kunene.
My name is Ketluwazi Kunene, and I'll be taking over to briefly discuss some of our abstract use cases. We had the user signs in with verified Google account. User selects and uploads student record from a local file system. The user adds a scholarship. User edits or updates scholarship criteria. User deletes a scholarship. User filters candidates. User generates letters to save as documents. User saves documents to local file system. User generates emails. And user manages outstanding student award. For the high-level use cases, we had this use case begins with the user opening the application. This use case ends with the user signing in to Google API. This use case begins with user opening their local file system. This use case ends with the user uploading a CSV file with student records. This use case begins with the user adding a new or existing scholarship. This use case ends with the user seeing the scholarship in the scholarship list. This use case begins with the user selecting a scholarship from a list. This use case ends with the user modifying that criteria for qualification. This use case begins with the user selecting a scholarship from the list. And this use case ends with the user removing the scholarship from the list. Furthermore, we still have this use case begins with the user selecting a scholarship on the Generate Letters tab. This use case ends with the user receiving a list of qualified candidates. This use case begins with the user selecting candidates from a qualified candidates list. This use case ends with the user generating documents. This use case begins with the user selecting a file location on their device. This use case ends with the user saving those documents. This use case begins with the user creating emails for candidates with the generated documents attached. And this use case ends with the user sending emails to the selected students via Gmail. This use case begins with selecting outstanding student criteria, and this use case ends with selecting candidates. When we evaluated our use cases, we grouped them using the communicational partitioning because we didn't really have multiple users. There's only Dr. Loba, so role-based partitioning wouldn't have made sense for us. And the way that we chose to partition these is through use cases that relate to scholarship management, as well as use cases that relate to the acceptance letter management. When evaluating our use cases in a table, the ones that will be broken down into expanded use cases are use case 1, use case 3, and use case 7. For the login and expanded use case, we had the precondition where the user must be a member of the MSU faculty, and they must be accessing the application from the MSU computers. And it also follows the order that this use case begins with the user opening Scholarly. Then the user is prompted to sign in. The user then enters valid or invalid credentials, to which either a login is allowed or not allowed. And then if a login is not allowed, then the use case will continue back at step one, as the user will then have to re-log in again and enter valid credentials. Or otherwise, the use case just ends with the user accessing the Scholarly application. A use case diagram for this use case would look something like this, in which the actor has the ability to open Scholarly as well as close Scholarly. But once they've opened Scholarly, then they sign in, to which a Google Authenticator is then accessed in order to verify their credentials. The scenario, as explained, the user opens the Scholarly application from a computer at MSU and completes the login process. This is the expanded use case for analysis. Now, adding a scholarship. For this expanded use case, we looked at the precondition where a scholarship must exist and student records must have been uploaded. The use case begins with the user selecting the Add Scholarship button. Then the user is prompted for scholarship information. The user then saves that scholarship, and the scholarship appears in the list of scholarships, to which then this use case can continue with the user editing the scholarship, or it can also continue with the user deleting the scholarship, to which we show an alternative route through a different use case here. Use case 4's expanded use case shows the process of actually, if you see here, editing the criteria. The use case begins with selecting an existing scholarship, and the precondition is that a scholarship must have been added. Then information associated with the scholarship is displayed. The user can select criteria or a limit, and either one of these adjusts different criteria. And then the use case ends with the user saving these new changes. For the adding scholarship use case, the diagram would look somewhat like this, to which the user, who is the actor, can add a scholarship, edit a scholarship, and delete a scholarship. And once a scholarship is added, we take that information and store it within our database. And if a scholarship is also deleted, it is removed from our database. The user selects the Add button on the Manage Scholarships tab of Scholarly application, and they are prompted to enter the scholarship's information and criteria. This is the expanded use case for analysis. For the Generate Acceptance Letters expanded use case, we had the precondition that scholarships must have been added or must exist, and there must be qualified students. For this use case, it begins with the user selecting a scholarship. Then they are returned a list of qualified candidates, from which the user selects a candidate to generate the document. The document is then generated for the user. And then this use case continues with the user either saving the document, or it continues with the user emailing the document directly after creating the document. For this, we looked at use case 8's expanded use case, where we see the precondition that the acceptance letter has been created through use case 7. This use case begins with the system prompting the user to save a file, to which then the user uses their system to select which file or folder they'd like to save the acceptance letters. The file is saved, and the user is then prompted to view the files. Then the use case continues with the user opening files on their local device, or the use case ends with the user closing the prompt. For the generate acceptance use case diagram, we have the system here, as well as the actor. The actor can save a document, generate the document, or as well as email the document directly. If they were to save the document, it would then be handled by their local file system. However, if they were to email the document, then it would be handled by Gmail's background processing. The user selects a scholarship as well as candidates from the qualified students. Then they create an acceptance letter for that student, after which they provide information on their credentials, and the document can then be stored locally on their device, or it can be emailed directly. This is the expanded use case for analysis. For one of our incorrect use case examples, we looked at use case 2. We used the precondition where student records must exist. And for this one, we showed some processing happening where the system prints choose file location to the user. Then we show that after the user opens a file location, the system does nothing. And then the user selects a student record, and the student record is temporarily saved to database, and it does not end with the actor either. We also have use case 5 here incorrectly shown. The precondition is also that a scholarship exists. Here we have the use case begins with the user selecting a scholarship, then the system does not respond, and then the use case ends with the user deleting the scholarship, and the scholarship is removed from the database. For the accomplished work, Angel's accomplished work, he came up with the architectural design objectives as well as the architectural design considerations. He identified types of subsystems and overall system, identified the architecture of our system, applied software design principles, the final contributions to the development of the scholarly application itself, as well as identified use cases, designed block diagrams for systems and subsystems. And the accomplished work that I achieved was deriving use cases from the requirements, as well as identifying the abstract use cases, coming up with the high-level use cases, partitioned our use cases, designed use case diagrams, as well as the expanded use cases, identified scenarios, and designed the scenario tables. This is the presentation video. Thank you very much.